This is Thylacoleo Carnifex, or better known as the marsupial lion. It was a terrifying apex predator that lived in Australia during the Pleistocene epoch, being able to take down prey the size of rhinos despite weighing only 160 kilograms and possessing the highest bite force relative to its size of any mammalian predator ever. It was one of the deadliest carnivores Australia has ever seen. And this is the koala, its closest living relative. In fact, all of the remaining close relatives of the thylacoleonids are peaceful herbivores. To understand how peaceful herbivores evolve into a terrifying killer, we have to first look at the vombatiformes, the suborder that includes the marsupial lion family, Thylacoleonidae. The vombatiformes are one of the three major suborders of the massive marsupial order, the Protodontia. They first appeared in the fossil record during the late Oligocene epoch, approximately 25 to 26 million years ago, with some lineages still surviving today. Although the suborder gave rise to a wide array of animals varying greatly in sizes, from the rhino-sized diprotodon to the river-slade dwarf koala, which was only 1/3 the size of a modern koala, almost all of them specialized in a fully herbivorous diet. Well, with the exception of one family, and you guessed it, that family was Thylacoleonidae. You might be thinking now, how did an otherwise entirely herbivorous suborder give rise to such a hypercarnivorous family, with all the anatomical limitations, such as teeth made for grinding plants? Well, the answer is simple. They didn't just suddenly grow sharp canine teeth or claws. Evolution simply did what it does best, repurposing and modifying existing body parts. If you examine the skull of members of Thylacoleo, the last and most highly specialized genus, you will see exactly how evolution repurposed their teeth. The large, terrifying bolt cutter-like teeth found in their mouth, which resembles the carnassial teeth seen in many modern carnivorans, were actually enlarged premolars modified for shearing flesh. This is unlike the actual carnassial teeth found in placental carnivorans, which are modified molars. Furthermore, Thylacoleo did not have real, functional canine teeth. Instead, those were replaced by a pair of giant, almost forward-facing incisors. Ironically, the rest of the Protodontia used these exact same incisors to gnaw trees and cut plants, not hold on to prey while their flesh was sliced by giant premolars. This transition didn't happen all of a sudden either. If you examine the skull of members from the older genera of Thylacoleonidae, like Wacaleo, you can see exactly how the transition worked. This early marsupial line already had one of the most defining traits of the Thylacoleonids, the elongated third premolar. However, it still retained some more primitive, transitional features, such as molars, which members of the genus Thylacoleo later lost to maximize its bite force. This demonstrates exactly how the family began prioritizing slicing meat over grinding plants. The repurposing of body parts originally used for herbivorous lifestyle doesn't stop there either. Most Thylacoleonids had a semi-opposable thumb used to grapple, pin, and disembowel prey. Tree-dwelling vombatiformes, such as koalas, also have opposable thumbs. And this is no coincidence. The semi-opposable thumbs of the Thylacoleonids is an inherited trait from their direct, tree-dwelling herbivorous ancestors. But instead of using these thumbs purely for climbing trees, the Thylacoleonids use them for, well, more violent things. The biological phenomenon of repurposing existing body parts for a new function is called exaptation. These fascinating anatomical traits just show how unique the marsupial lines are. They didn't need to grow terrifying canine teeth or razor-sharp claws. They just repurposed what was already on their body for hypercarnivory. Now we have how they became lethal predators settled. Cool, but what actually caused it to happen? Evolution doesn't just make a koala a jaguar-sized hypercarnivore just because it looked awesome. There must be a reason. The answer is quite complex. Small, less specialized Thylacoleonids existed, but how late-stage hypercarnivorous Thylacoleonids, like the infamous Thylacoleo Carnifex, evolved mainly boils down to several climate and geological factors. During the Oligocene and Miocene epochs, Australia drifted north, separating itself from what was Antarctica and isolating itself from the rest of the world. Because of this isolation, native species in Australia did not have to compete with the placental mammals which dominated Laurasia, an ancient supercontinent far from Australia. During this period of continental shifting, Australia underwent a long-term drying and cooling trend over millions of years. This climate shift destroyed the dense jungle habitats that smaller marsupials lived in, and the lack of cover forced animals to grow to gigantic sizes to avoid predation and to process rough, fibrous plant matter. Among these giant marsupials were the gigantic rhino-sized diprotodon species that weighed up to 2.8 tons. The sheer abundance of giant megafauna prey combined with a total lack of mammalian competition ultimately gave rise to deadly apex predators like Thylacoleo Carnifex. If you think you learned something from this video, please consider subscribing. Thank you for watching and have a good one.